Does that make sense now? So the verifying, so basically it was an easy way for me to grade verifying. You understood the order that they go in without having to look at all the little parts, right? So the first thing I'm going to do, so I'm not even going to look probably at this yet. I'm just going to start here, and I'm going to try to do the problem. Okay, and then I'm going to try to see if my steps are there in order. Okay, so the first thing I'm going to do, well, my first thing that I would start with is the original, right? That's step B. So tangent squared x, cosine squared x. That's step one, is whatever you're starting with. Okay? Alright. One method I could choose is, couldn't I turn things into sines and cosines? Okay, so how would I turn tangent into sine and cosine? So sine, the idea was meant to help you kind of jog your memory, right? The other reason behind it. So sine squared over cosine squared, if all right. Is that one of our choices? Which choice is it? G. Good. All right. Now what? The cosines cancel, so what's left behind? Sine squared. Is that one of our choices? Which one? F. Guess what the last choice has to be? Yeah, the 1 minus cosine squared. So choice C is the 1 minus cosine squared. Okay, so not so bad, right? It looks pretty scary when you first look at it, but it's not so bad. Okay, I'm going to show you a second way to do it. Okay, because there were actually two different correct answers. The second way has one extra step. Okay, so I'm going to start the same way I did before. Alright, so I'm starting same step, right? Tangent squared x cosine squared x. Now, I could go to Pythagorean identities, couldn't I? So look up there, what's another name for tangent squared? Secant squared x minus 1. Is that one of our choices? Yes, which one? It's h. Okay, so let's go there. So we've got h. And basically, it's an open-ended question, so you got to type it in. So you type in the answer BGFC, right? Or BH, whatever this one is. Let's see. Now, what's your instinct telling you to do here? Distribute. So secant squared x cosine squared x minus cosine squared x. Okay, is that one of our choices? Which one is that? So now we're going to use D. Okay. Alright, so we've got D. Alright, and then I would probably try to go to sines and cosines. So what is another name for secant? Because we're always looking for opportunities to cancel, right? It's our favorite thing to do. Is that one of our choices? It's E, right? Alright, and then the last one, what happens with these guys? They cancel, and we get to the final answer that we wanted, because guess what? That should be the end answer, right? So C. Could I have gone backwards? Yeah, but they have to be in the right order. Don't type commas, don't type spaces, just type the letters in order. It doesn't matter if they're uppercase or lowercase. So I would expect to have seen BGFC or BHTEC. Okay? No, one or the other. Pick one. Okay, but I wanted to make sure you understood that there were two ways to do it. Because we didn't use all the parts in either one of the ways, right? So you might not use all of the parts because there's extra. There might even be something extra thrown in there to throw you off. Okay, so it's better to go through your own thinking and then try to find it in the answer. Okay. All right, that was 24. Denise, which one do you want? 13. Okay, let's go to 13. So we're working on it, and I may record all the periods today, just so because they may pick different things. Right? All right, that's fine. 13. So we're going to do the double angle. All right. So I don't think triangle is tangent is negative 3/4. In SOHCAHTOA world, what's tangent? Opposite over adjacent. So remember, the little sign is still hanging up there by the flag, right? You can still look up at that if you need it. All right, so opposite is 3, adjacent is 4. Which one of those is going to go negative? The 3, good. And then 3, 4, what for my Pythagorean? 5, good. And if you don't know it, use the Pythagorean there. Okay. All right, we're supposed to only be finding sine of 2u. We're not making you find like 3 or 4 of them. Okay. So we need you to look up the double angle formula for sine of 2u. What is it? You guys, if you have your notebooks out or the yellow books, it should be there, right? Your notebooks are probably better. Starts with a 2, okay? 2 times what? Sine u, cosine u. All right, what is the sine of this triangle? Good, and then the cosine of that triangle is 4/5. Good. All right, so it doesn't look like anything cancels. My denominator is going to be what? And I don't know why I do the denominator first. All right, 2 times negative 3 times 4 is what? Negative. All right. All right, we good with 13? All right, Sky, you're next. Which one do you want? 6? Okay. So we go back to 6. Okay. So on this one here, you have to actually verify it. There'll be a few of these where you actually have to show me your verification steps. And remember, it's the steps in between that I'm grading, not the first step and the last step, right? So which side is more complicated, the left or the right? The left. Good. What do I see in the left side? So I can pull it out. What's that called? Greatest common factor. So I'm going to take out a greatest common factor of secant squared x. So what am I left behind with? Tangent squared x plus 1. All right, which color sign should I go look at? Pink Pythagorean sign, right? So look up at your Pythagorean sign. What am I allowed to replace tangent squared x plus 1 with? Good, secant squared x. And then secant squared times secant squared is... And remember, make sure they look like exponents. That one almost doesn't, right? Because you now have squared and we also have 2x. So we got to be really careful, right? So did we get what we wanted? Okay, what I would grade is those 2 steps in between and likely off your paper versus off the computer. Okay, so make sure you're grading it clearly, okay? All right, we good with 6? All right, Jesse, you're next. What would you like? 11. Okay, and then Allison, you're after Jesse, okay? Make sure you got one in mind you want to do. All right, rewrite the expression in terms of the first power cosine. Probably one of my least favorites. It was better than what was there originally. I don't know if I didn't catch it till later in the day. I changed this problem from what we had on yours. We did it in class, okay? Because the one that we had on there was really, really nasty. Okay, so we changed it to try to make it better, and this is still pretty ugly. Okay? It may or may not get better for the test. Maybe this one's cosine to the 4th, maybe I put sine to the 4th on the test. Okay? So there always has to be one on there that's a challenge. Right? Okay, so first thing I'm going to do, if I'm going to go to first power cosine, these are the power reducing formulas when you see that. Okay? So you need to look on your chart and look for the power reducing heading. Okay? All right, so power reducing is all in squared, so first thing I need to do is convert it to squared. So I'm going to go cosine squared. Okay, so cosine squared x squared. All right, here is where we replace it for the first time. There's going to be 2 replacements of power reducing in this problem. Okay? Most of the power reducing are like this, unfortunately. All right, what am I going to put in there for cosine squared for power reducing? Read me the formula. Okay, and instead of u, we're using x's, right? All right, what does squared mean? We write it twice, okay? What about the 2 at the bottom? What is that going to become? 4. And couldn't I write it as 1/4 and get rid of the fraction out the bottom? So that's kind of one of the techniques we've been working on. And then we write 1 plus cosine, and I'm going to write every little step. Some of these steps you can, some of you can skip. 1 plus cosine 2x. Sometimes, especially for test grades, it helps spread all the steps so you don't miss it. All right, what do I have to do with that? Boil it. Okay, so we've got 1 times 1 is 1. 1 times cosine 2x is, and how many of those do we have? Here's the thing where we double it, right? When the signs match, we double. When the signs are different, I think somebody was struggling with that yesterday. When the signs are opposite, that's where we only do first and last. All right, cosine 2x times cosine 2x is cosine squared, right? 2x. Okay. Are we in the first power of cosine? Not yet. We have to deal with this squared thing at the end. Alright, so we gotta deal with this guy at the end. Alright? So I'm gonna use power producing again. Because if I try to do Pythagorean, it's just gonna give me more squares, right? Try to get rid of the squares according to their instructions. Alright, so help me out. I'm gonna have to put something in there. I know it's over 2. What is the formula for cosine squared? 2. Okay, so 2 of the u, that whole thing is the u. So what am I subbing in? 2x. Good. Okay. So we've got 1/4. 1 plus 2 cosine 2x. I'm going to go ahead and split it into 2 fractions right now. So 1/2 plus 1/2 cosine of 4x. Okay. All right. It is probably going to be a multiple choice question, and I'm sorry to say that's not the answer. Okay. First thing I'm seeing is that we should probably combine the 1 and 1 with 1/2. So what do I get when I do that? 2 halves plus 1/2 is 3/2 plus 2 cosine 2x plus 1/2 cosine of 4x. Okay, and I'm sad to say that's also not going to be multiple choice. Okay. What they're going to do is they're going to pull the 1/2 out front. Okay, so they're going to factor out a 1/2. And this is where it kills me with sometimes with test writers because they do some funky algebra at the end, and that you get here and then it messes you all up, right? If we know it's coming, you can practice this a couple times tonight, or you have all weekend, right? The test's not too new. Practice it a whole bunch. All right, so I'm going to turn this guy here into halves because he's the only one that's not in halves. So what do I have to multiply that 2 by to get into halves? So right now over 1. So I get a 4, right? So 4 halves cosine 2x plus 1/2 cosine of 4x. And this is probably one of the longer ones on the test. All right, so see how there's denominators of 2 on all of them now? We're going to factor that out. So I'm going to have 1/4 times 1/2, and then I just go to all coefficients without fractions. So 3 plus 4 cosine 2x plus cosine 4x. All right, so it's 1/4 times 1/2. 1/8 3 plus 4 cosine 2x plus cosine 4x is behind this. That one was super. Okay. But again, you had it pretty much solved in that line right there, right? But I'm pretty sure it's going to be multiple choice, and it's going to have some weird fractions. All right, so practice that one 5 or 6 times, right? We've got enough time between now and Monday to do that, right? All that's going to possibly change is I can put a sign in there, right? Okay. I'm not going to put tangent, try to mess you up that way. All right, Allison, you got one? 3. Okay, so review number 3, and Abby, Mandiola, you're next, okay? So have one to do that. opposite. So do I need to do all of FOIL? No, all I'm going to do is first and last. And you guys are really good at recognizing number one that, number two that we're FOILing, not factoring, right? All right, so what's tangent times tangent? Tangent squared x, and secant times negative secant is negative secant squared x. All right, there are two ways you can do this from here. Okay? So, you may or may not pick up on one of the identity, okay? So I want you to look up at the Pythagorean, the pink sign. Okay, and on your sheet you'll also have Pythagorean identities. But the pink sign, remember, I solved them all out for you. Whereas on the sheet that's going to be in front of you, they won't be all solved out. Okay? Look up there for tangent squared minus secant squared. Is that up there? Not exactly, right? What's different? It's the other way around. The signs are different. So could I do the little trick where I factor out negative 1? I can do that. So then that would make the tangent squared negative. I'm just going to reverse the order. And the secant squared positive. Now what can I replace for that? I can put in a 1, so my final answer is good. The other way I could go, okay, is could I just replace the secant squared? That's another perfectly valid way to go. What goes in for secant squared? 1 plus tangent squared. If you didn't want to mess with the distribution, could you replace tangent squared? That should work too. Okay, and then you don't have to mess with the distributions. Either way, there's 3 different ways, very good ways to solve something. We're going to do 2. So negative 1 minus tangent squared, what's the key here? The tangents are going to cancel and I get to negative 1. Okay, so and then there's one more. I could replace the tangent squared, and then the secants would cancel and we get negative 1. Okay? We've got 3 different methods to solve it. All right. Addie, which one do you want? 14? Sure. And then Abigail, you're next, okay? Alright, number 14. Okay. So you hopefully have a half angle formula in front of you. That was better on the inside front cover of your notes notebook, right? For the reference on that, it's the very bottom, squished in between stuff, right? How do we know it's a half angle? It's over 2. It doesn't explicitly say in this particular problem it's a half angle, but you've got that over 2. I believe it shows that on the chart, right? It shows the theta over 2 or u over 2, okay? So you know that you got to match that formula up. All right, so in the half angle, let's just write out the half angle formula so I know the parts. Why am I writing something? All right, we got to write cosine. All right, so cosine of theta over 2. All right, so give me the formula. What's it say? 1 plus cosine, in this case I'm going to use theta over 2. So what is the only thing I need to get off of that triangle? I only need cosine. Can I read it right off the triangle? What do I still need? I need 13 on the hypotenuse, right? So we know 5, 12, 13, and if not, use your Pythagorean theorem. Okay? Alright, so now what is the cosine of that triangle? 12 over 13 over 2. What's a better name for 1? Yeah, I should put 11, right? Okay, so now we're going to do a couple of steps at once. Good at it. What's 13 13ths plus 12 13ths? 25 13ths. Good. This is technically 2 over 1. What were we doing with that? Flipping and multiplying to 1/2. There's no good way to reduce it, right? So what do I get across the top? 25 over 26. This is square root of 25. 5 over square root of 26. All right. I should probably rationalize it, right? So that last rationalize step, you could almost look at your multiple choice answer and just write it down, right? have to go. Which one do you want? Number 1. Is that right? Okay. And then Sandra, you're next. Okay. Okay, so we're gonna go back and look at number 1 here. It says that we have to find all 6. Likely on the test, it will pick on 1 or 2 at the most. Okay, it might not have you find all 6. Alright? But I'd rather you practice all 6 so you know how to get all of them from whatever information you've got. Okay? Alright, so I get 2 for free, don't I? Which 2 do I get for free? Secant and tangent. Okay. So secant, I'm going to do flip the reciprocal on cosine. And unfortunately, we have to rationalize that. So 2 squared and 2 over 2, what happens? The 2's cancel, and I get square root of 2. Okay, so I got that one. I have to flip the reciprocal on -1. What do I get? -1. All right, we never went and looked at which quadrant we're in. That's important to probably the last 2 to make sure our signs come out right. Okay. All right, so cosine is positive. Which quadrants is cosine positive in? 1 and 4, right? And then which out of those 2, which one is cotangent negative? 4. So I'm a quadrant 4, which means my sine and my cosecant better come out negative. Okay. Now there's lots of ways I could do this. I could reverse the tangent. I could use triangles. Okay, if you remember how to do the triangles that we did earlier in trig, you can use that on the test. I'm not saying you can't. I'm going to show you how we did it this game. Okay. I know I can either relate the cosine to the sine, but there's some ugly radicals that I got messed with. This one is a 1. That's a much nicer number to work with. So I'm going to use the Pythagorean identity where I relate cotangent and cosecant. So I'm going to use 1 plus cotangent squared equals cosecant squared. There you go. That pink sign, first column, last formula, right? All right, so what is the cotangent that I just got? -1. And it was something they originally gave to me. So again, if they originally gave it to me, I know I'm not messing it. It wasn't one I possibly messed up in a reciprocal. Okay. All right, what is -1 squared? 1. Okay, and 1 plus 1 is 2. How do we undo the square? Square root. What do we write in front? But for this one, for cosecant in quadrant 4, what do I really want? I really just want the -1 because it's quadrant 4. So for cosecant, this is the correct answer. Okay. How do I get sine? I flip it, so I'm going to go -1 over square root of 2, rationalize, and really considering that one of our other answers was square root of 2 over 2, this shouldn't surprise us, right? Don't we know that on the unit circle they go together? You could have probably almost guessed it from your unit circle. Okay. All right, Sandra, which one do you want? 15 and Jamie, you're up next. Okay. And after Jamie, the class gets to pick 4 more. Said 15. All right, let's look at 15. All right, so on 15, where are we going to read? What heading are we going to read under on our charts? Product of sum. All right, so we're going to go to the product of sum. We're going to read the formula. What's the formula? 1/2, and then for cosine times sine, what operation in the middle? Addition after the sign is, and then sine, and in parentheses, subtraction. Okay? And then what do I do with these guys? Plug it in there, plop them in, right? Okay. What is 3 theta plus 2 theta? 5 theta. We didn't do anything tricky like put a pi in there to get the evaluate, right? Sine, or 3 theta minus 2 theta. 6 theta, done. Right. The product sum and the sum of product should are not intended to be challenging. They're intended for you to show us the understand which formula to apply and apply. Okay? Alright, Jamie, which one do you want? 16. Alright, 16. This time what heading am I looking under? Sum to product. And notice, we're only put 16 questions on the test. You only really interested in demo that you understand how to do each one of these things one time. Okay, so there's not a ton of room for error. Alright, so what number do we start with in our formula? 2. Okay, I've got a sign plus a sign, so what's that first piece of trig? Sign, what operation? Addition over 2, and then what? Cosine, and what operation? Subtraction over 2. Alright, so what am I plopping in now? 4x and 10x. And remember, they have to go in order. Even though it's going to make a negative, we're going to have to deal with that. Right? Alright, so what's 4x plus 10x? 14x over 2, and then 4x minus 10x is over 2. Alright, 14 divided by 2 is 7x cosine of what? Alright, negative 3x. Now, that may be the answer, but I doubt it because of the negative on the inside. So this is where you got to use your green sign, or on your sheet, even odd identities. This comes from the even odds. Okay? So on the cosine, does the negative move out front or does it disappear? Disappear. So I've got 2 sine 7x cosine 3x. Alright, so for all the people who did partials, the class gets to pick 4. So, which 4 do we want that are left? Just give me one of them. So shout it out. There's something you really want, now's your chance. Number which one? 8. Let's go back to 8. Alright, there's number 8. This is the multiple angle solutions one. You would need your unit circle for this, but again, we're going to have the unit circle on the chart, right? It's there. You can have your own out too. I will come around and check it one last time. Make sure you don't get the x right. Alright, so is cosine the x value or the y value? X value. So I need you to look around your unit circle and tell me where does the x value, what radian measures the x value? Pi over 3, 5 pi over 3. Now, there's an extra catch on this one because we've got a 2x there. So you set it equal to whatever's here, that's what it gets set equal to. How do we move the 2's? Divide or multiply by the reciprocals. Is probably the better way to go. So we get pi over what? 6, and then 5 pi over 6 is our 2x. Alright, you've got 3 left. Let's do 1c. We haven't done yet. 12. Yes, over 12. Alright, gotta simplify the expression. Alright. This one doesn't have the name of the formula, right? But there's only one sign. This is the sum difference formula. So this is the sine, cosine, cosine, sine, cosine, cosine, sine, sine stuff. Okay? So, with sine because I have one sign and a minus sign, or a plus sign in this. Okay? If I have 2 signs, that's so 2 of the trig signs, I have sum to product. Okay? Alright, so what's the sign pattern? There you go. Alright, and what operational symbol goes in there? Do I keep it or change it? Keep it, and we plop in the angles. Am I allowed to leave sine of pi over 2 and cosine of pi over 2? No, I need to go to my unit circle and evaluate that. Pi over 2 is up here at the top, right? So what's the sine of it? So 1 times cosine x, what's the cosine of it? 0 times sine x, sorry, what happens? 0 times sine goes away, what's my final answer? Cosine x. co-function identities? Oh. Yeah, you could use your co-function identity too. Okay, does that make sense? Everybody look at the origin sign up there. Isn't it a direct set directly equals to the co-function? Yeah. So two ways to do it, right? You could have also done the co-function if you recognize it. So you got two, there's no reason to get it wrong, right? There's two ways to do it. Alright, so you can practice either one. Okay? Not sure we saw that. But you know what on the test? Could it be something other than pi over 2? You can only use the co-function if it's pi over 2. So if it was pi over 3, can you use co-function? No. Okay? So I would be prepared that it isn't a co-function. Alright, so I would probably aim for this practicing the sum of difference just in case the co-function doesn't. Okay? Alright, you got two more. What else? 10? You're not going to like this. Okay? All you literally have to do is figure out how to go to the next step. We ultimately want to, we already were in tangent, right? We switched from tangent to sine over cosine. What's going to happen? So write down what it would look like. So you would write down cosine squared x plus sine squared x. And you can check it with the next line. What's cosine squared plus sine squared? It's meant to just so you can demonstrate you understand the steps, but to help you, and that I only have to grade one line. Okay. All right, last one. What else do we want? Or I can stop. One more. Do you guys have enough done yet? 4? Okay, let's look at 4. 4 is going to be our last one. You're going to just have to go with the answer key. You may check though. I may try to video all day. Let's see. They may pick different ones to do this. Just aim through their video. All right. It says use fundamental identities. That means I could really use any of them on the chart. Well, this was kind of towards the beginning of what we did, so would probably more in the Pythagorean world. So go ahead and look up at the Pythagorean sign. What am I going to replace? Cosecant squared minus 1. Cotangent squared. That's probably not as simple as I could get. Because what could I do with cotangent? Yep, so cosine squared over sine squared. Why was that beneficial? Cancel the sign, so I'm left with cosine squared x. Okay. Alright, then it might be multiple choice, so you might have some answers there at least to verify that you're on the way. Okay? Alright, I'm done. That's where we can stop.